Hi, everybody. So my name is Alicia. I'm a genetic counselor at the Children's Hospital of Philadelphia. And I gave this talk yesterday actually for the science meeting, but I wanted to give this talk again, maybe framed a little bit easier to sort of understand and go over some of the updates that we have from the ProMMiS natural history study for Syngap, so as to hopefully make some of that kind of a little bit more accessible. So I'm just going to quickly go over the design of the study, and then we're going to talk a little bit about recruitment, and then because we are now 2.5 years into the natural history study, I'm also going to talk about some of the things that we are doing with the data that we've collected, as well as some of the new directions that we're hoping to head in. So this slide is just sort of an overview of what the protocol looks like for the ProMMiS natural history study. And the way I would think about natural history studies is they're studies that are designed to help us understand what a particular condition looks like over time and in different people, right? Because we know that everybody who has a diagnosis of Syngap isn't going to be exactly the same. So it's really important for us to understand what are people like over time and kind of what is the full spectrum associated with Syngap look like in different people. And that's really important for sort of two reasons. One, for clinical counseling, right? Because we want to understand when we talk to a family, when we give a new diagnosis of Syngap, what should we be telling them? What should we be telling them to expect? What kind of medications might be best for treating their seizures? What kind of therapies might be the most helpful, right? Those are really important things for us to understand as clinicians. And it's also really important for us to be thinking about what we call clinical trial readiness, particularly for a condition like SYNGAP1, where we're really hopeful that there might be clinical trials for targeted therapies in the near future. When we go to design those clinical trials, we need to understand what people with Syngap are like so that we can understand whether those therapies really made people any better or they didn't. So understanding what the natural history is of Syngap and what people are like is going to be super important for designing those trials in a way that can make them successful. So for the Children's Hospital of Philadelphia, this is a sort of example schedule of what it would be like for a family visiting to participate in the natural history study. So families come for kind of the whole day to do a whole barrage of different developmental scales and meet with a bunch of different specialties. So people meet with neurology, developmental pediatrics, genetics, as well as physical therapy and occupational therapy and speech therapy. And we do both clinical visits, so giving advice to families, as well as doing standardized assessments, which are meant to sort of measure what people's development or seizures are like. And we do also, around the time of the visit, collect parent-reported outcome measures. So these are more like surveys that are given to the caregivers because we think it's really important for us to also be capturing kind of what the lived experience is like for you guys at home and what the perspective is of the parents and caregivers as well. I'm not going to belabor this slide too much because compliance is not very exciting, but we are collecting all of this data in a way that is designed to be extremely rigorous so that we could hopefully use this data in future clinical trials potentially as a control and to make all of that data compliant with what the FDA would expect for a clinical trial. So to give you guys some updates on recruitment, the original goal of the ProMMiS natural history study was to recruit 100 people who have SYNGAP1 related disorder. We are already way over that number. There are 117 people so far that have been evaluated just at the Children's Hospital of Philadelphia site for this study, as well as more people at Colorado and at Stanford. And you can see there the yellow line represents the total number of visits and the blue line represents the total number of people. So it's 117 people, but we've actually done way more visits than that because we have families coming back every 6 months so that we can check in with people over time. And now we have people, because this study's been going on for 2.5 years, who have been coming for their second, third, fourth, and even fifth visits. And we have people who come to us from all over the United States. You can see us sort of all spread out. And we've even had some people come from outside the country, from Canada and Argentina and the UK. And then we have people seen at one of 3 different locations. So I'm from the Children's Hospital of Philadelphia location, but we also have study locations that are open at Colorado Children's in Denver and at Stanford in California. And we are all sharing sort of data behind the scenes. All of it is the same ProMMiS natural history study. So people can be seen at one location, and then later, maybe if they move or it's more convenient or a new site opens up, they can be seen at another site, and we can still connect all of that data. So now I want to switch gears a little bit and talk about kind of what we are doing with all of the data that we're collecting as part of this natural history study. And the first thing that we're trying to do with that data is reconstruct what epilepsy looks like over time for people who have Syngap. So this is a giant figure that shows you each row is a person with Syngap. And each dot represents 1 month of that person's life, and the color of that dot represents how many seizures that person is having in that particular month. And we sort of create these figures by asking for epilepsy histories and asking people about their seizure history when they come to visit us. And then we can look at how the epilepsy profile is different in Syngap than it is in other genetic epilepsies. Like, for example, here you can see it compared to STXBP1, which is another genetic epilepsy that we do natural history work for. And you can see in Syngap what's kind of unique about Syngap compared to other DEEs is that the seizures in Syngap often start a little bit later, often sort of between the ages of, say, 2 and 5. But once those seizures start, they can be very explosive, they can be very frequent. That's why you see a lot of that very dark red color, especially right at the beginning when people are first being diagnosed with epilepsy and they're trying to figure out what medications might be useful. And so we think that overall, about 80% of the people that we've seen with Syngap have epilepsy at some point in their life. And about 50% of people with Syngap are having seizures actively at any given time. And this is really important for us to understand, not just sort of at this broad level of seizures in general, but also more specifically for the different types of seizures that are most common in Syngap. So here you can see the 3 most common, which are myoclonic seizures, atonic seizures, and absence seizures. And all of those are relatively frequent seizure types in Syngap, which is different from, say, generalized tonic-clonic seizures. Those are those like big full body shaking seizures like you would expect to see in the movies. We think only about 10% of people with Syngap ever have one of those big full body shaking seizures. Whereas by contrast, lots of people have these seizure types. And this is super important for us to understand because these seizure types, while they can be very frequent, they can also be hard to recognize, and they can also be very hard to count, especially in people who maybe are having, say, 50 or 100 seizures in a day. That would be impossible for us to ask a parent to count that reliably every single day. And the reason that that's super important for us to know is because seizures are often used as a clinical trial endpoint. And so understanding how we can count seizures, how we can quantify seizures, how we would know if seizures get better or worse in a particular person is super important. So this work has been, really useful in helping inform how we think about that. We do also collect a lot of data about developmental scales. So these are tests that measure what a person's development is like. One of the tests that we do is the Bayley-4. It's designed for children between 0 and 42 months of age, but we do actually do it in all different people with Syngap throughout the lifetime. And you can see that what we generally expect, so this is the gross motor and fine motor parts of the Bayley, is we expect to see people with Syngap gaining skills over time and improving their developmental skills over time, even if it's on a different timeline than we would expect from a neurotypical person. And with the motor skills, we see a relatively smooth progression. So in general, we see people getting better in a pretty predictable way. Whereas this is actually a little bit different than what we see on things like receptive communication or expressive communication, where you can see that those lines really jump up and down a lot more. And you could have a person do really well on the test one day and then a lot less well the next time they come in. And we think that this is not so much a reflection of what development is necessarily like in Syngap, but we think this is really being impacted by behaviors in Syngap, because I'm sure I do not need to tell anyone in this room that behavioral challenges is a big part of what families with Syngap are dealing with, and that's going to be reflected in natural history data as well, right? We expect to see that if a child is having a good day on one day, they might score higher, and if they're having a bad day the next time, then they might score lower. And again, this is super important for us to understand because we don't want pharmaceutical companies going into a clinical trial thinking that every child with Syngap is going to have a good day every single day. So it is our job as clinicians and researchers to make sure that when we design trials that they account for this kind of variability. And we see a similar thing in the cognitive score of the Bayley as well. Another one that we use is the GMFM. So this one looks at gross motor skills as well. You can see it's kind of more like the Bayley. It's a little bit more of a smooth progression. And then we also do the Peabody, which we've been really pleased to see a lot of really good data come out of this related to fine motor skills, so things like hand manipulation and eye-hand coordination that we think are important to kind of quantify because we know these can be real challenges for people with SYNGAP. So that sort of is our main body of our work that we work on the most, but we do have additional projects that we're getting up and running as well. So these are things like quantitative EEGs. We do an EEG for every person who comes through the natural history study, and that's to help us understand how SYNGAP impacts the background electrical activity in the brain. We have also started adding motion sensors to the natural history study as well, so we're just starting to collect those. And then our newest thing that we're going to be sending home with people is watches that can do sleep actigraphy. So this is a way of measuring the quality and the duration of people's sleep, because we know that that, again, can be a huge challenge in SYNGAP, and is going to be something really important for us to be able to understand and quantify. Another thing that we've come across as we've been doing the natural history study is we came across some inherited cases of SYNGAP1 where they were passed from a parent who themselves had symptoms to a child who also had symptoms. And we noticed that a lot of those variants were located right at the beginning of the gene. So this has led us to do a lot of work as well on trying to understand whether the location of a person's genetic variant is important in predicting what their symptoms might be like as they get older. And as of right now, the only sort of strong correlation that we've identified is that we think people whose variants are very early in the gene, in exons 1 to 4, might be a little bit more likely to be towards that milder end of the SYNGAP spectrum. And that's not a sort of perfect correlation, right? Certainly every individual is still going to be a little bit different from everybody else. But that, again, is going to be super important for us knowing how to counsel families, knowing how to tell families what to expect. And it's possible that we'll find other genotype-phenotype correlations as well. As we get more and more people in the study, we are more and more powered to detect these kinds of correlations. And certainly this kind of work has never been possible before because there's never been such a large data set of people with SYNGAP to draw from. So just to summarize, we went over a little bit of the protocol design, the recruitment for the study, and an overview of some of the things that we're doing with the data and some of the projects that we're sort of working on now and hoping to continue working on in the future. And I think big takeaway from the natural history study for the last 2.5 years is that we've really learned a tremendous amount about SYNGAP1 and what it looks like in different people. And I think that's going to be tremendously valuable in informing how we think about doing things like clinical trials in the future, and in making sure that we as clinicians can do, the best that we can do to counsel families and tell people what to expect and tell people what might be helpful or not helpful to them. So with that, I want to thank everybody that is on the team. This kind of natural history research requires a lot of super smart, super talented people. So a huge thank you to them. And then also a huge thank you to all of the families in this room, but especially to the families who have come as far as Philadelphia to see us. None of the work that we do would be at all possible without you guys, and we have had such an incredible buy-in from the community on the natural history study. So a huge thank you to everybody in this room and everybody in the family community.